point that we'll look at is segmentation. And segmentation is exactly as the word suggests. We are assigning an ID to each of the uh, first dimension. So if we have a two-dimensional matrix, those are going to be the rows of the matrix, and we'll assign groups and we'll perform some mathematical operations on each of those groups, and it'll get clear as we go through this example. First, we'll create an tensor tf.constant, and this is going to be a two-dimensional tensor. So with values of 0, 1, and 2 in the first row, and then we have the second row with values 4, 5, and 6. And finally, in the third row, we have values 1, 1, and 1. So if we print x, we should see that this is a tensor. And what I'm going to do in these videos is, rather than printing this whole output for the tensor, we'll convert it to numpy by typing dot numpy open close parenthesis, so that we just see the array that we have in the output. Next, what we need to do is create segment IDs, and for segment IDs, we'll simply use the variable y, and these are just going to be this is just going to be another tensor which has values such as 0, 1, 1, and these we are calling these as segment IDs. And the way these are set up is 0 refers to this first row, this 1 refers to the second row, and this one refers to this last row. And now if we perform any operation, let's say we want to add the values, so we can say tf dot math dot segment underscore sum, and inside of this we pass in the value of the tensor on which we would like to perform the operation, and then we input the segment IDs which are in y, and then if we try to print the output, if we print the output for z, we should see so let's see, y is not defined because I didn't run that cell. Okay, so here we have the values which are the summed values by segments. The first segment is by itself, which is segment 0, and that is going to be just this row 0, 1, 2, and that is what we see in the output. The second two segment IDs are 1, 1. So if we so we need to add these element wise. So we are adding 4 with 1, that becomes 5. 5 plus 1 is 6, and 6 plus 1 is 7. So we get the output 5, 6, 7. So what essentially we tried to do is we created two groups, and this row was in one group, and these two rows were in another group. Let's look at another example of how we can use this. If you notice, the way these segment IDs are presented here, they are in an increasing order. So we have the 0 first followed by 1s, and those are called as those are sorted in a way. And if we use the unsorted, so if I were to use uh, if I were to change this, and let's say we change this to 1, copy, I'm going to copy this, paste it here, then copy these two lines of code and paste them here. And what we are going to do is change this to 1, change this to 0. Now these are unsorted, right? So because the 0 comes after 1, these are unsorted. And if we try to run this now, it should throw an error. And so segment IDs are not increasing. And therefore, what we want to do to be able to use this unsorted IDs, segment IDs that we have here, TensorFlow has another method which is called unsorted. So if we specify unsorted underscore segment underscore sum and then run this, in that case, we still get an error, and this error is saying that we are missing a positional argument number of segments. So if we use unsorted segment, then we need to specify number of segments, and let's say number of segments. In this case, we just have two segments. So one segment is identified by 0, and the second group is identified by 1. So we'll specify 2 here. And now when we run this, we get the output, which is 4, 5, 6, and 1, 2, 3. So if we look at x, this is our x we have, and in this x, the first row is 1, last row is 1, so we need to add them element wise. 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3, and so get the 1, 2, 3 right here. And the segment ID 0 refers to the second row, 4, 5, 6, which is by itself, and so we get the same exact values here in the output, which are 4, 5, 6. So this is how we can perform the unsorted uh, unsorted unsorted segment sum. And let's now look at yet another example of what we can do. Is let me go ahead and copy the same lines of code, because we are going to use the exact same lines of code, and I'm going to create a copy of this and set this as y x. So we have a new set of values, and here we'll create 1, 2, 3, 4. So those are the values, and then right here, let's say 1, 0, 0, and we have 1. Now again, it's the same setup. We have uh, x. We have then the segment IDs. These are not this. This is just values that we are working with. And then we have the segment IDs. We perform the unsorted segment sum, and we get the values of 5. How we got the 5 is this way. If we look at segment ID 0, we need to add 2 plus 3, that is 5. And then for segment IDs 1, we have values 1 and 4, so we add those two and we get value of 5. Next, we can look at yet another shape of x. So uh, we could put square brackets around this. So we have another shape for the input values of x. And now if we perform the same operation of unsorted segment sum, we get the output values which are identical to what we had before, but the shape of the output is different. We have a 2 by 1 matrix here, array here in the output. Finally, we can look at yet another example, which is similar to what we have seen earlier, but this is for using without the unsorted part. So if we say we would like to perform the segment sum, and the segment IDs are very well sorted, we have the increasing order 0, 0, 0, 1, and if that is the case, if we run this, we see that with the segment sum, we do not need the number of segments argument, so we are simply going to delete that. And now when we run this, we should get the output uh, as expected. We have the first set of IDs with value, says first set of IDs 0 have the values 1, 2, 3, which add up to 6, that is here. And then the segment ID 1 has just one value in it, which is 4, and that's the value we see here in the output. So that was it for this video. In the next video, we'll continue looking at another functions in TensorFlow math. Thank you.